The first part of the question wants us to find the velocity of the chain. To do that, I chose the point particle system of the chain, and I used the work energy principle. I set work equal to force times change in direction. So the center of mass only moved the distance d minus half the length because it's in the middle of the chain. And you just work it out, you multiply, break down kinetic energy, and then you find your final velocity here. Next, we want to find the total change in energy of the system. To do that, I chose the real system of just the chain. And since the chain is my system, I have to find the work done by the surroundings, which is the person pulling the chain. So you do work again is equal to force times change in direction, and you plug in the values that were given. This time, the entire distance, because we're not looking at the center of mass, we're looking at the whole multi-particle system, and we find our final value here. Next, we're looking to find the change in thermal energy. To do that, we know that the total change in energy is equal to the change in translational kinetic energy plus the change in thermal energy. We already know the change in total energy, and we can find the change in translational energy pretty easily. We just go back up to the point particle system that I set up with the work energy principle, and we plug in the value V that we already know, and we can get our final change in translational kinetic energy here. We subtract the two, and we get our final answer. And really, if we wanted to make it easier on ourselves, since these two values are equal, the total change in translational kinetic energy is right here already. So you don't even need to plug in the velocity that we found earlier.